So here's an example using the price of a 2-year zero coupon bond. So this was the price in the up state going from time 1 to time 2 using the upper interest rate, and this is the price from time 1 to time 2 in the lower interest rate. So what we can, and of course each one of these is equal, this is equal to 1 over 1 plus RD, this is equal to 1 over 1 plus RU. So we could price the 1-year zero, the 2-year zero, using these bond prices or their interest rate. So we put $1 in each place, and then we have to calculate a value here. And we can, by taking the expected present value, it's a 1/2 of this times the 1/2 of this, and that's the same as using present values. That's the 8116 is. And it's the present value at time 0. So we just saw that 0.8832 is the price at time 1 of a 1-year zero using the up interest rate, and this is the price of the 1-year zero using the down interest rate. This comes directly from that table. Now we have to do two things. One is we have to take an average of these, 1/2 of the price in the up plus 1/2 price in the down. So we have an up and a down price. We have to do a risk-neutral expected value. And then what we have to do is to discount this back to time 0 using either the original interest rate, 1 over 1 plus R, or the price at time 0 of a 1-year zero. And that price was 0.9091. So if we take an average of these prices, which introduces the risk-neutral expectation, that only brings us to time 1, and then we need to go back to time 0. This calculation is identical to the calculation we saw earlier, where we had the original R, this was RU, RD, and I put $1 in each place. I have to do a risk-neutral present value, and that's what I got when I averaged these two prices. And then going from here to here, I have to use R, or the price of that 1-year zero. Exactly the same calculation is done in the 3-year. These are 3 states of this goes from time 2 to time 3. So in pricing the 3-year bonds, we again start with the prices at year 2, and these come directly from the table of 1-year bonds. But of course what we could have done is extend the lattice to 3, and put $1 at the terminal point, and the 0.8321 uses these two interest rates and a risk-neutral probability of 1/2, and that's where the 0.8321 come from. If I use these two interest rates with the $, I get the 0.87. So although we already had the 1-year zero coupon bond prices at time 2, we could have done this calculation exactly the way we did it earlier, which is to put the $, at time 3 and then do expected present value. This price, these two prices come to here, these two prices come to here. And in each step, we're using the p-value and the interest rate value.